In this video, I'll be working through the question you see on the screen here from the Maths Paper 1-3 from 2024 Cambridge A-Level exams. If you're looking for a different question from this paper, have a look in the description below. There should be a link to a playlist. And if you're looking for a different paper entirely, have a search on my channel. I'll be doing all this on a whiteboard, hopefully just like you're used to doing in the classroom. But remember, we're not in the classroom, we're on YouTube, so take advantage of that. Pause, rewind, even watch it at a different speed. If you find this video or any of my videos useful, I would greatly appreciate a like, a subscribe, a share, or even a super thanks.
Question 5 starts off, they give us this equation of a curve here and simply ask us to find the coordinates of the stationary point. That's already a clue, there's only one answer here. So it's not points, it's just point. Okay, how do you find the stationary point? You should be thinking dy dx. You should be thinking derivative. So dy dx, what does that equal? And that's what we're going to start with. Well, actually, I'll rewrite y. Y is equal to 2x squared minus 1 over 2 x to the power of minus 1. Much easier to differentiate when it looks like this, I think. You do you. So let's differentiate this. We get 2 times 2 is 4, and we take 1 away from that, we get x. We get minus 1 times minus a half is plus a half, and we take 1 time away from that, minus 2. Derivative of a constant doesn't change when x changes, so that's the derivative is 0. You could rewrite this if you want as 4x plus a half, or plus 1 over 2x squared. Either is fine. You've got marks for differentiating, but what they really want to see when they're talking about a stationary point is dy dx equals 0. If we solve for this, we'll find the answer. So yeah, let's try and solve for it. Let's move things over the equals, and we'll get 4x is equal minus 1 over 2 x squared. Let's multiply 2x squared across. We get 8x cubed is equal to minus 1. Let's move the 8 back. X cubed is equal to minus 1 over 8. What's x equal then? Let's just do it down here. X is equal, well, this can be done in your head. The calculator will do it for you, of course. Well, here, let me do what you'd write in the calculator. 1 over 8 to the power of a third. But again, we can do this in your head. Cube root of 1 is 1. Cube root of 8 is 2. A cube root of a minus is actually a minus. Or you could say the cube root of minus 1 is minus 1. Cube root of 8 is 2. Anyway, the answer is minus 2. X is equal, sorry, minus a half. They didn't ask for just x though, they asked for a stationary point. So be careful of that. They did want y. So let's put it back in here. Y is equal, let's see, 2 times minus a half squared minus 1 over 2 times minus a half plus 3. Again, your calculator will do this if you're not that good at it. But 2 minuses make a plus. Two halves multiplied make a quarter. A quarter of 4, that's a half. Let's see, 2 times minus a half, that's minus 1. Minus 1 divided by minus 1, that's plus 1. And then plus 3. So what are we at? 4.5 or 9 over 2. So the stationary point they're talking about is minus a half, 9 over 2. Next for part B, they want you to determine the nature of this stationary point. That just means, is it a maximum? Is it a minimum? Is it neither? I guess you can have stationary points that look like that. Are they stationary points? I can't remember. There's always straddle points, stationary points, maximum, minimum. I think that's a stationary point. Anyway, how I'm going to do this question, I'm going to do a couple of different ways. I'm going to do the proper way that the examiner wants you to do. But I'm also going to do a little cheat way that I did accidentally when I started this question. When I start any question, I draw it. If I can draw it, I draw it. And drawing this question actually answers B and I guess C as well, I think. So if I try and draw this function up here, I think of 3 places. I think of plus infinity, minus infinity, and 0. Now in this case 0, dividing by 0 will get me in trouble. So I better think of approaching 0 from the plus and approaching 0 from the minus. You don't have to do this, but it's a way to answer it. So let's do all them. What would happen if this was minus infinity, minus a big number? Well, minus by a minus would be a positive, massive number. 1 divided by a minus big number would be so close to 0, I don't care. 3, I don't care either. This guy's so big, I don't care. So basically when I get to minus infinity, I'll have a really big number. So I'll be up over here. When I get close to 0 from the minus side, let's see, this guy get really close to 0, he'll be gone. This guy here will be, when the bottom row gets close to 0, this will become infinity. Well, let's see, there's a minus, and I'm approaching from the minus side. So we have 2 minuses. So I'm starting to approach infinity up here. So this will look something like this. Maybe it looks like this, I don't know. I don't want 2 of them there. But it will look something like that. It'll have a shape like that on the left side. I don't know if it crosses the x-axis. I don't care. And then if I'm getting near 0 from the positive side, that'll become 0. This will become a plus infinity by a minus. So I'll be somewhere down here. So I'll come up from down there. And then when I'm a really big number, that's a really big number. When I'm a really big number, that's 0, and I don't care. So I'll be somewhere over here. So I don't know what it looks like. It looks maybe something like that. So that's my rough drawing of this function. So when they ask in part B, what is the nature of this stationary? Oh, I know where this is. It's at minus b plus. Okay, let's draw that in again then. My first guess was right. So when they ask for the nature of this, I know it's a minimum because of my drawing. And you could say some of that in English. And that's not what they want you to do though. What they want you to do, and yeah, let me clear off some of the board. I'll leave the drawing though. I'll clear off some of the board and I'll explain what they really want you to do. To determine the nature of this, they wanted you to get the second derivative. So let's get the second derivative here. Second derivative of this is just 4. Second, I'll do this one a bit faster, is minus 2 times this is minus 1, and it's x to the minus 3. That's the second derivative. We know this point, sorry, I've rubbed that out, minus a half 9 over 2. What the first derivative does, it tells you if it's going up or down. What the second derivative does is it tells you if it's if it's going up and going up even more, or if it's going up and going up less. That's what it tells you. Is it decelerating or accelerating? So when it's bigger than 0, it's accelerating, and you end up getting these shapes. When it's less than 0, it's decelerating, and you end up getting these shapes. So less than 0 gives you a maximum, bigger than 0 gives you a minimum. So we just put in this number and see whether this is bigger or less than 0. So put minus a half in, we get 4 minus 1 minus half to the power of minus 3. Do that in a calculator if you want, but remember it's just in the bottom row. So it's minus 1 to the power of 3 over 2 to the power of 3. It's minus 1 over 8. On the bottom row, flip it over, we end up with 4, 2 minuses, plus 8 equals 12. Do it in a calculator, do that slowly. 12 is bigger than 0, therefore minimal. And that's all they want to see, bigger than 0 and minimum. That's what they pretty much want you to do. There is another way to do it. You knew this was the point you're interested in. You could have tested something just a little smaller than a half. So say minus 0.6. And then you could have tested something bigger than a half, minus a half. So minus 0.4. So test that guy and test that guy. And put this into the derivative. And if this one is going down, as it is, this one will be going up. So the minimum must have been somewhere in between there. That's another way to have done it. Okay. Oh, sorry, there's part C. Part C, for the positive values of x, determine whether the curve shows a function that is increasing, decreasing, or neither. Again, my drawing answers that. It shows a function that's increasing. That's it, you're done. If you did a drawing, you spoke something about that, that's not what they wanted. Once more, they wanted you to see, let's see, they wanted to see the derivative again. Let me write here, dy dx Because if they're asking about increasing or decreasing, they want to see the derivative. So they want you to write the derivative x to minus 2. And they wanted you to point out that x is bigger than 0. Now that you can use English or you can talk through this, but I would say something like, from this, when x is bigger than 0, I'd even write that, I'd write when x bigger than 0, 4x is bigger than 0. A half is bigger than 0, that's always bigger than 0. What's this? This is 1 over x squared. Well, that's bigger than 0 as well. Therefore, dy dx is bigger than 0. Something like this they wanted to see. And they wanted to see, they want you to actually answer the question. So I guess they want you to write increasing. Is your answer increasing? But you could have also, if you were able to draw the picture, it would have answered both of those. Okay, if you have any follow-up questions for anything I waffled on about there, let me know in the comments. I'll do my best to answer. Thanks for watching and have a great day.